This is lesson 117 on mass and weight. It's really important that we distinguish between mass and weight because they're not the same thing, and yet a lot of people confuse these two terms. Having taught 8th grade physics for a long time and even high school physics, I know that the importance of this distinction. So let's get into what these two terms mean. Mass is the amount of matter in an object. Some of the units that we use to describe mass include grams and kilograms. These are metric units. Weight is the force of gravity on an object's mass. Today we're going to be talking about the U.S. customary units of ounces, pounds, and tons. But if you're asking yourself, well, what is the metric unit for weight? The metric unit for weight is actually called a Newton, okay, named after Sir Isaac Newton. And weight is the force of gravity on an object's mass. Now, I think the reason that we confuse mass and weight is because we find mass and weight using a scale. We use the same object usually to find something's mass and weight. And so we think, if I'm putting something on a scale to find its mass, and then I put something on a scale to find its weight, I must be finding the same thing. But let's think about this for a second. Say you put an apple on a scale and you find that it weighs 100 grams. So its mass is 100 grams. In other words, the amount of matter in this apple is 100 grams. Now, we're going to launch this apple out into outer space. I don't know why, but people do things like that. So we're going to launch the apple into outer space here. And we find that the amount of matter in this apple has not changed. It's still 100 grams. However, the weight of the apple as it's floating through space is very different because the effect of gravity on that apple is now different. So when we're on Earth, okay, the force of gravity is always the same. And so we can use the same tools to find an object's mass and to find an object's weight. I can't take this scale into outer space and find an object's mass at all. This scale is calibrated to Earth's gravity, and so I can use it to find an apple's mass here on Earth only. Okay, so hopefully I've cleared up a little bit of that confusion and have not added to the confusion. So let's start with metric units. Metric units of mass are measured in grams. A paper clip is about 1 gram, and 1,000 grams make up 1 kilogram. So our first example says 2 kilograms is equal to how many grams? Well, remember how we set this up in using unit conversions. I'm just going to multiply 2 grams times 1, right? I'm making a giant 1 because my 1 is going to be composed of a fraction. I made this a little bit better. And my fraction has the same and equivalent terms on the top and the bottom. So 1,000 grams is equal to 1 kilogram. And I put kilograms on the bottom because I want to be able to cancel out kilograms. So now I get 2 times 1,000. So I get 2,000 grams. And that's my answer to example 1. Next, we're going to look at customary units. It's customary system. We have, in your book, it shows a picture of an envelope is about an ounce, a shoe is about a pound, and a small car is about a ton. And a ton is 2,000 pounds, and an ounce is 16 ounces. So example 2 asks us to subtract 7 pounds, 12 ounces from 9 pounds, 10 ounces. Well, we're going to start here with the ounces. And we can see that there's more on the floor, right? We cannot take 12 from 10. So we have to, now remember that 16 ounces is equal to 1 pound. So we have to add 16 ounces to this 10. So that gives us 26 ounces. And we have to take a pound from here. That gives us 8 pounds. Okay? So 26 minus 12 is 14 ounces. And 8 minus 7, of course, is 1. So that gives us our answer there. All right, hopefully you enjoyed this lesson. You learned a little something, and I look forward to seeing you all again. Hope you're having a good day. God bless.